How do you solve this problem? Well, it's pretty cool, so let me show you. So you basically have two vector components. That is as if you had two sides of a right triangle, and you need to find the magnitude of the vector f, which is the hypotenuse basically. And you also need to find the angle theta, which is the angle with respect to the x-axis. That's the entire problem, so let's solve it. First of all, we're going to we're going to draw the two vector components. So let's do first Fy, should be something like this, and this is going to be 10 newtons. And now let's do our horizontal, well, our x component, which is going to be 2 newtons, okay? And now our vector would look something like this, okay? And now in this drawing, we really care about having an x-axis, which, well, we care about the angle between that axis and the vector, okay, which is going to be theta. And now, well, hopefully you can see this is basically just Pythagorean theorem, what you need to do, that is a right triangle. And now, well, let's do it. So let's find first the vector, the vector magnitude. So this is going to be f, this is going to be f. And now we know that since f is the magnitude, that means that the length of the line must be f, or well, the magnitude of the vector component, the vector f. So if this is the length, that means this is the hypotenuse. And we can find the hypotenuse by using the Pythagorean theorem. So we're going to have that the magnitude squared is going to be equal to 10 squared plus 2 squared. This is the same as 104, okay? 100 plus 2, plus 4, I'm sorry, yeah. And now we need to, if we need to find the magnitude for vector f, this is squared, you can take the square root on both sides. And now let's see how much that would be. So if we have 104, that is the same as if we had 52 times 2, okay? This is the same as if we had 26. So this is going to be 26 times 4. 26 times 2 times 2, which is going to be 26 times 4. This is 13 times 2. Yeah, we can leave it like that. And this is just going to be 2 times square root 26, okay? And this is, of course, newtons. This is how much you get. Yep, that's perfect. So now, what do we need to do in this case? Well, now we know how much the magnitude of the vector is. I'm going to write it up here. So we know f is going to be equal to 2 times square root 26 newtons. And now let's find the angle theta. Now this is pretty cool. If you need to find this angle right there, well, something you could do is you could try to use any trigonometric function. So for example, let's use tangent. So we know that, I'm going to write that, tangent of any angle theta is equal to the opposite side over the adjacent side. And now in this case, theta would have an opposite side of 10 newtons. Remember, this is the y component. You can just bring it here if you want to see it as the opposite side of theta. So this is going to be 10 newtons. That looks like it's 16. This is going to be 10 newtons over the adjacent side, which is going to be 2 newtons. And this is just simply 5. Okay? Remember that since we have, we're basically finding the value of tangent of theta, which is just going to be 5. This has no units. Now, how do we find theta? Well, we now can take arc tangent. So we can say that theta is equal to arc tangent, which is the same as if you had tangent to a -1 in your calculator. You might be used to that notation, but this is the same as if, I'm going to write it here so you don't confuse it. This is tangent -1 or arctangent of 5. And now let's see how much that is. So let's use our calculator. And this is going to be 78.69 degrees, okay? So basically now we can just simply write here that theta is going to be equal to 78.69. degrees, of course. And this is basically the entire solution for this problem right there. We have two vector components. We have, well, we're being asked to find the magnitude of that vector and the angle between the line that represents that vector and the x-axis, okay? So now this was pretty cool. This is just simply some Pythagorean theorem and some trigonometric functions. It's pretty simple. So I hope you enjoyed this video, and well, smash the like button and see you in the following one.